Hi everybody, today we're going to be talking about, we're going to do a quick review on slope-intercept form, which is on the screen right now, and we are also going to be talking about parent function. Okay, but before we go into parent function, which is our new topic, let's do a quick review of slope-intercept form. Okay, so slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. Okay, so here's some try on your owns. I just want you to write it in slope-intercept form. So here you have the slope and the y-intercept. Here you have slope and a point, which you can use the stuff that we talked about the other day and in class today to try to help you figure out what slope-intercept form looks like. You have 2 points, and you have a graph. So go ahead and do these 4 problems. When you come back, I'll have the answers, and then we'll move on to our new topic. Okay, so for A, since we have a slope and a y-intercept already, you should have y equals negative 1/3 x plus 4. B, you'd have to either plug this into this form of y equals mx plus b to get b first and then figure it out, or you can use point slope form and then change it to slope intercept form. But either way, you should have gotten y equals 9x plus 19. C, you needed to find the slope first, which ended up being 2/11ths, and then either again put it in point slope form and change it that way, or put it in y-intercept form and find the b and then write out your equation. Either way, you should have gotten y equals 2/11ths x minus 21/11. So, and then D, all you had to do was find the slope, which is rise over run, so that's 3/4. I think I did this wrong. 3/4. No, I didn't. 3/4. And then the y-intercept was 3, so y equals 3/4x plus 3. Pretty easy. So let's go ahead into the new stuff then. So parent function. First, before we do parent function, let's talk about families of functions. So functions are classified based on their shape. We've talked about linear. We will talk about quadratic, but linear is just a straight line. Quadratic actually makes a curve. There are lots of other different functions that you'll learn later on in math. But that's how we classify functions into families based on their shape. So a group of functions with the same characteristics. Here we're going to be talking about linear. Okay? The parent function is actually, click. It's not showing up. Hold on. Fade in, or just none. Weird. Okay, there we go. Oh, there. Well, now you can read it. The parent function is actually the simplest function with these characteristics. So for linear, we have y equals mx plus b. The simplest way to write it would just be all we need is the x and the y. Okay? So a linear function, none of this is showing up for whatever reason. Oh, that's so frustrating. Oh, it just wants to be annoying. Because it knows I'm trying to make a short video. Alright, well, there. The linear parent function, oh my gosh, this is really irritating me. Oh well. The struggles of being a math teacher, guys. So this is the linear parent function, where it's just y equals x, meaning the slope is just 1, goes up 1/1, so it's a positive 1, and the y-intercept is actually 0, so it goes through the origin, okay? You've seen this. This is actually also a direct variation, alright? So, let's go on to the next thing. Hopefully this will work. So now we're going to look at how we can change, like using the parent function, we add stuff onto it, what it'll look like. So we graph the parent function first. You might need to pause the video and draw this. I just pre-drew it. Okay, in black. And I strongly recommend you use different colors for this. You don't have to, but it's just easier to see if you have it in different colors. Color coding is so much easier. So here we have our parent function. This is what it looks like. It goes straight through the origin. It's the perfect diagonal of the graph. But now we're going to go ahead and graph y equals negative x. So this is different than the parent function because of that negative 1. We're going to graph that in pink. Let's see. Oh, yep, it does show up, thank goodness. So it's going the opposite direction. So again, what's the difference between the line, the black line, and the pink line? Well, the pink line's going down while the black line's going up, because the pink line has a negative slope and this one has a positive slope. So really, that negative sign in front flips the whole line. It just flips it. It's like exact reflection. So it actually is a reflection. Whenever you have the sign of the slope changes its reflection. Okay? The graph of the parent function, it says graph the parent function. So I think you guys already have it done, because I'm pretty sure I only gave you one graph for this. So just add these lines onto your graph. It says to graph y equals x. Y equals x minus 3 in red. So same slope, so it's going to be parallel to this. It just has the y-intercept of -3. So I'm going to start down here. There you go. And now I'm going to graph y equals x plus 5 in blue. So again, parallel, but it's starting up here. So how are the red and black lines different? Well, they're exactly the same, except the red line is just down 3 units from the black line. It's lower. So it went down 3 units. That's called a transformation. You might have talked about it last year in Math 7 Honors. But when we move it up or down, it's called a translation. So here, we can only move a line up or down. We can't move it left or right. So when it goes down, another way of saying it is that -3, which is the y-intercept. So that means it went down 3 units from the parent function. Same thing with the blue. It actually got moved, where'd it go? It went up 5 units, so plus 5. That's why it has the plus 5. This is all compared to the parent function. Okay? It's very possible to compare two lines that neither of them are parent function, and we do it the same way. We'll probably do a bell work or an exit ticket on that. But okay, I think now you guys have a new graph, so please redraw the parent function in black. Okay, if you need a minute, pause the video. But now we're going to go ahead and graph the y equals 1/2 x. So this is different from the parent function in that the slope is different. This number is smaller than 1. So when we graph the yellow line, I think it's right here, yep. If you look at it, look, it's not as steep, right? So how are the black and yellow lines different? It's less steep. So if the slope is less than the parent function slope, it's going to be less steep. But if the number is greater than the parent function slope, what do you think? Right? It becomes more steep. Okay, so how are the black and green lines different? It's steeper or more steep. Okay? So transformations. We got reflection, which is the flip line, which is a result of that negative in front of the slope, that negative sign. We got translations where it's being moved up or down. So when the y-intercept is positive, it goes up. Negative, it goes down. And then the last one, where'd it go? Is steepness. The steeper, it's either steeper or less steep. The bigger the absolute value, meaning the number of the slope, not the sign, the number of the slope, the steeper the line. If it's less than 1, then it's going to be less steep than the parent function. Okay? But even if you had 2, like -2 and 1/2, -2 is actually steeper than 1/2, because I'm just looking at the number 2. That has the bigger slope, so it's a steeper line. Okay? If you need a minute to write this stuff down, please pause the video. Okay? So, now we're going to go ahead and try some examples. Describe the transformation of the following from the parent function. So we have y equals -x plus 9. So here's how we're going to do it. We're going to go through those 3 criteria and answer to see like what kind of change happened. Was there a reflection? What's going on with the translation? What's going on with the steepness? Okay? So reflection is based on the sign of the slope. So here we have a negative, so this is a reflection. Okay? It's plus 9, so that means it went up 9 units. And it's got a 1 for the absolute value of the slope, which is the same as the parent function, so it's the same steepness as the parent function. So you should have 3 things to classify or describe your transformation. Reflection, yes or no. Did it go up or down, and how many units? And if it didn't, just say no translation. And steepness, is it the same? Is it steeper? Is it less steep? Okay, so you're going to try these 2 on your own. When you come back, I'll have answers for you. Okay, so number 2, we've got a negative, we've got a fraction that's less than 1, and we went down 4. So it is a reflection. 4/5 is less than 1, so it's less steep, and it went down because it's -4, down 4 units. Okay? 3, you probably wanted to change this into slope-intercept form so you could see it. So you really should have had y equals negative 1/4 x plus 1.25. I think that's what it should be. So here's, yes, it is a reflection because it's got a negative in front of the slope. It's less steep because 1/4 is less than 1. And we went up 1.25 units because that was we had a positive 1.25 or 1 1/4 or 5/4. Sorry, school just let out. It went up, okay? So, and that's it for the video. So I finished just in time for the end of school. If you have any questions, please write them down. It's a lot of practice and we'll do more practice in class. But other than that, have a good day. I'll see you next class. Bye. Oh, I don't know why I say bye before I finish the recording. Now I'll say bye. Goodbye.